So exponents and logs are basically inverses of each other. So they have this inverse property where we have the exponential function and its mirror image across this diagonal line represents the log function. So the domain and range of this exponential function is going to be all real numbers for the domain, and the range is going to be from 0, greater than 0. So then the domain of this log function becomes greater than 0. So we can't take logs of negative or 0. And the range is going to be all real numbers. So we should know what the basic log function graph looks like. This helps us interpret log problems. We also want to change the base of log. So first of all, we need to know the change of base formula. The change of base formula basically is going to be the log of the argument divided by the log of the base, and we can change it to whatever base we want. Now, in calculus, the best base to use is e. So we want to use what we call the ln function, or the log function. So it's going to look like this. So we're going to change this to base e by just making this log x over log 4. Okay, so we want to really change everything to the natural base. Everything works much better when we use a natural base. So for this one here, for these ones here, we're just going to change these all to the natural base e. Okay, and if you're not sure what e is just some number like pi. Okay, e is approximately equal to 2.718 ... It's a special number that comes up everywhere. Okay, it's an irrational number. It's what we call a transcendental number like pi, and it just seems to show up everywhere, and it works perfectly for math. Okay, so we have this log function. We're going to change it to base e. We're just going to use the change of base formula. So we just take the log of the argument over log of e, and then we can evaluate this in our calculators because all our calculators should have a base e log in it. Here we're going to do the same thing. So we're going to do log 4e squared over log 3. Now, anytime you have an argument that is compatible with the base, we really should work it out. So this becomes log 4 plus 2 over log 3. Here we're going to end up with log 3x over log 2. This one we're going to convert this is base x, and we have power x. They're not really that compatible. So we're going to put into log. So we'll end up with log e to the 3x over log x. And there's nothing really we can mix here because, again, this is a base x, it's an exponent x. They don't really mix with each other, so we're just going to leave it like that. Okay, there's no real simplification here. Although we should probably work this out. Log 10, and e to the 3x just becomes 3x. Okay, and because it's times, we're going to combine them with a plus.